Hi everyone, it's Coach Fred here, and so I wanted to talk about domain and range. There are four ways that you can find domain and range: symbolically from an equation which means algebraically; graphically by scanning the x-axis for the domain or scanning the y-axis for the range; numerically, so from ordered pairs, tables, or mapping; and then descriptively, I like to call this as the reasonable domain and range. So I've created four videos here on each one for you to get an idea of domain and range. Okay, so today we're going to look at symbolically. So when we find domains from a function equation, you're looking at an equation. So given a function, we need to remember that the domain of the function is the set of permissible inputs, like the ones I'm allowed to put into the equation. And the range will be the resulting outputs. So domains can be found algebraically. Ranges are often found more graphically, but can also be found algebraically. And algebraically just means you look at an equation and you determine the domain. So when finding the domain of a function, I want you to ask yourself, what value or values make the equation undefined? What value or values make the equation undefined? Your domain is everything else. All right, so let's look at some examples. First, we want to know that there's some basic rules to consider. The polynomials that you've learned in Algebra 1, linear functions and quadratic functions, these domains are simple. They're all real numbers. Why? Well, there's no x I'm not allowed to plug into the functions, into either one of these. I can plug in -1,000, I can plug in a half, I can plug in 0. There's no limit, there's no unpermissible outputs. So for quadratic functions and linear functions, it's just going to be helpful if you remember their domain is all real numbers, and you'd write that with interval notation, -infinity, infinity. Now, I just explained why, but it really is important for you to think about domain and range as inputs and outputs. If I put this into my calculator and graphed it and looked at the table would give me every single x value that it could, and it would keep going and going. And because of that, it's going to give me every permissible output, okay? So now the domain and the range for a quadratic, the range is going to be different. And for a linear equation, for now, we're going to talk about that the range will be -infinity to infinity. The range on a quadratic function we'll talk about later. I'm going to do it in class. We're going to look at the graph to help us, okay? But the range relates to the vertex of the parabola, okay? But for now, the domain of quadratic and linear functions is all real numbers. All right, so that's our basic rules. Now let's look at some other ones. Square root functions are a totally different story. They cannot contain a negative underneath the radical. You have learned that, if you got a square root under a radical, or a negative under a radical, something like maybe that, you know that you're getting some type of imaginary number. Your teachers probably told you just couldn't do it. Well, you can do it. It's not a real number. So to find the domain, we want to find the values that's going to make whatever's under the radical negative. So really, to find the domain, just set the expression under the radical greater than or equal to 0, because that will give you all the values that will make x greater than or equal to 0, so non-negative. So for example, x minus 3 is greater than or equal to 0. All right, so I add 3. So I want x's greater than or equal to 3, which would mean hard bracket 3 to infinity. So that is my domain. Right now, again, we're just finding domain. All right, this one's a little harder. 2x plus 1 is greater than or equal to 0 because I don't want the value to be negative. It can be 0, it just can't be negative. So by stating that, that statement means greater, all positive numbers and 0. So we're going to subtract 1 and then divide by 2. So x is greater than or equal to -1/2. All right, interval notation. Hard bracket, -1/2, comma, infinity, parentheses. All right, final domain here. We take the expression, set it greater than or equal to 0. Solve for x. You might already see that something interesting is going to happen. Now we need to divide by a negative. There's that dividing by a negative. What do we need to remember? Should be able to hear you say it. That's right. We have to flip the direction of the inequality sign. So in this case, we want x is less than or equal to 3/2. So we have to flip around our domain. Remember, we always read left to right. So that means I want from -infinity all the way until I get to 3/2. So -infinity, comma, 3/2. Hard bracket, and the parentheses on the left of infinity. All right, so that's square root functions. It can be tricky, for sure. All right, the other one that we have to really pay attention to is rational functions. Rational functions are functions in which you have a variable of x in the denominator. It can also be in the numerator, but we're looking carefully at the denominator. Why? Well, we've talked about it. You can't have 0 in the denominator of a fraction. The value can't be 0. If it is, it doesn't exist. You have an empty set. There's no solution. So to find the domain, find, I call them the restricted values, the values that are going to make the denominator 0. Your domain, it's going to be everything else. All right, so in looking at this first one, I can see that x cannot be 4. So my domain is everything else. Okay, so this is where it gets tricky, is the interval notation for that. If I draw a picture of this, here I have 4. And I can't be 4, so there's like an open circle here. But it can be everything this way and everything this way. All right, so with interval notation, we would say -infinity, comma 4, because we don't want 4 included. Okay? And then we want to pick up on the other side of 4, so we have to have a union with where we want to start on the other side of 4, which again is parentheses 4 to infinity. Parentheses. All right, this next one. I have 2 restricted values. X cannot be -1, because if it is, then the denominator is going to become 0, and x cannot be 3. This one's a little trickier, okay? So think about a picture for yourself. Okay, x cannot be -1. X cannot be 3. But I want everything over here. I want everything in the middle. And I want everything over here. Yeah, that's tricky, right? I want all of this, and all of this, but I don't want -1 and 3. All right, so watch this. -infinity to -1, parentheses. Union, -1 to 3. Union, 3 to infinity. Okay? All right, so now I want you to try this one, okay? Press pause and come back. All right, so if you tried it, hopefully you noticed that first you actually had to factor it to find those values that make it 0. You can set it equal to 0 and then use the 0 product property, but you might just see that x cannot be 8, x cannot be 2. That means that it's similar to the first one, -infinity, comma, -2, parentheses, has a union with -2, comma, 8, parentheses, has a union with 8, comma, infinity. All right, so that was the lesson on finding domain algebraically. Have a great day.